Hey everyone, Michael Unger here with another edition of Ask an Astronomer. As always, with our trusted astronomer, just a couple doors down from me on unceded territory of Musqueam, Squamish, and Tsleil-Waututh, and that is Marley Leacock. Hey Marley, how's it going?
It's good. How are you?
I'm doing okay. Just outside, we've got some clouds, which is not what we want for our featured subject matter of today. And that's the event that is going to happen on Monday, April the 8th, something that is going to be spectacular only for people on the east coast of the continent. But for us, we'll still get something pretty cool as long as there are no clouds. We are talking about an eclipse. So if you're out there watching on YouTube, on Facebook, and hopefully eventually Instagram, if I can get it to work here. Just gotta people keep calling me here.
Busy, busy, busy.
It's a busy day. Get into the chat and let us know any question that you have under the universe, whether it's about solar eclipses or anything that you are curious about. We are going to go into the half-hour mark today answering all of your questions. So Marley, let's get into today's featured topic, solar eclipses. I was working here at the Space Center in 2017 when it was not a total solar eclipse. It was still a partial, was a bit bigger of a partial than we're going to get on Monday, but it was by far the largest event that we have ever done here at the Space Center. And that was largely due to the media excitement around the total solar eclipse that back then in August of 2017 was right across the mainland of the United States. So it went through tons of communities that saw it and ended up being the biggest viewed total solar eclipse likely in human history. And so this one's kind of matching a lot of that energy because that was not that long ago. People remember what that was like. People that saw the total solar eclipse back then are traveling to go see it again. So it's an exciting time, but maybe lots of people have been hearing about it. We're going to talk about it a bit more. Tell us about what a solar eclipse is.
Yes, of course. I think it was the city of Niagara has declared a state of emergency. I think like a million people are supposed to show up or something. So
Oh
my bad.
no.
Sorry, people of Niagara. I definitely told people to go there. So that's partially my bad. But um obligatory message at the top. Do not look at the sun without the proper equipment. We'll be talking a lot about observing eclipses and what they look like in the sky. You should never, ever, ever look at the sun ever without proper viewing equipment. And that's not sunglasses. That's specific, like even darker than sunglasses. It's very
Mhm.
specific equipment. Don't do it. You will damage your eyes, and you don't want that. The only time you can look at an eclipse or the sun is during a total solar eclipse during totality. So when the sun is entirely covered, that is not what we will be seeing here. So do not look at the sun. Don't do it. I have to say that. I have to. Okay. Here are the types of eclipses that we have. So there is a total solar eclipse, an annular solar eclipse, and a partial solar eclipse. And the differences between these three have to do with, for the first two, where the moon is relative to the sun and to the earth, and for partial and for the other ones, where you are, right? So typically, when we think about solar eclipses, we're usually thinking about total solar eclipses when the moon completely obscures the sun. But you only get that view if you are in the path of totality. For an annular solar eclipse, the moon is at its furthest point from Earth, and so it appears a bit smaller in the sky. And so if you're in the path of totality for an annular solar eclipse, you will see a ring of the sun still around, coming out from about the moon. If you're not in the path of totality, you'll end up seeing a partial. So you're just not in the right place at the right time. You don't have the right viewing angle for it to look like the moon is covering the entirety of the sun. Sometimes you also just get a partial eclipse where the moon kind of just passes in front of the sun and it's not in the right spot for it to cover the sun entirely, regardless of your viewing angle. So
Mhm.
these are the three different types of eclipses, and how they happen is a really fun combination of movement. So this is just another view about the differences between a total eclipse and an annular eclipse. An eclipse, all it is just when an object is temporarily obscured by either going into a shadow or by having another body pass between it and the viewer. So eclipses themselves are not that rare. Like everything that has a moon in the solar system has some sort of eclipse, right? Like there's tons of objects that will obscure other objects move around. What makes ours exciting is the fact that we get these total solar eclipses. So this is the viewing map for this upcoming solar eclipse. The path of totality is marked by this red dotted line. Whoa, my mouse is going so slow. This red dotted line is marking the path of totality. So that is where, if you're lucky to be in one of those cities along that line or within that range, you will be seeing, fingers crossed, the entirety of the moon covering the entirety of the sun. And the amount of coverage you'll see decreases the further away you get from that point. So us up here in Vancouver get a tiny, tiny little bit, about 17% coverage in this case. And since this has been such like a big thing in the news and I get getting a lot of questions about it, one of the more interesting questions I got about it was, why do we get solar eclipses? And also, what makes them so special? Why do we get total solar eclipses? A lot of questions of how come we get these? Because it's, like, why does this happen? And this is where I get to break out triangles. So
Yes.
remember, I did do a degree that involved a lot of math. And so sometimes that comes up, and this is one of those times. It does not happen often, but this is an excellent time to bring it up. So when we look at at the moon or any object in the sky, but in this case, the moon, we see the apparent size. So in astronomy, we measure the apparent size using degrees and arc seconds most commonly. I'm not going to explain arc seconds to you. Don't worry about it. It has to do with circles. We'll think about them in terms of degrees. It's called like an angular size of an object. And so how we determine angular size is by using a triangle. So you have the diameter of the object you're looking at, and you have the distance you are from that object. And then there's this angle theta. So theta, that is the angular size of the object. That's how big we see the object to be in the sky. The uppercase D is the true diameter of the object. So this mathematic triangle is actually how astronomers, like back of the napkin math and other things, figure out the true size or the actual distance from the objects we see in the sky, is by using this kind of math. And because it's a triangle and not just any triangle, a right angle triangle, that means we get to use trigonometry. So yes, yes, trigonometry. I think if people are watching, they've ended it because no one likes trig, but it's useful if you have the right kind of triangle, a right angle triangle, if you will. With trigonometry, we can figure out what theta is, right? So the tangent, if you take the tangent of this angle, that is the equivalent of having the opposite side over top of the adjacent side, right? So SOHCAHTOA, that's what we're talking about. And so you would take the tangent of this angle, that would give you the ratio of the distance over the diameter over the distance. But what's really fun is that if the distance is a lot larger than the true diameter of the object, you can just say your angular size is equal to the true diameter divided by the distance. And I promise this ties back into eclipses. I swear. So what is the angular size of the moon? How big is the moon as we see it in the sky, right? We can do the math. So the angular size of the moon would be its diameter, which is about 3,475 kilometers, over its distance, which is this huge number, about 0.009 radians, or about half a degree. So the moon in the sky, we see it, full moon from side to side, is about half a degree in how we would measure it. And what about the sun? We can do the same thing. We know that the distance from the sun to us is huge, so we can use the same approximation. The angular size of the sun is the true diameter of the sun over the distance from us. The diameter of the sun is huge, but the distance it is from us is even larger. And we get, oh, would you look at that, 0.009 radians, or about half a degree. So in the sky, when we look at the sun and the moon, they are about the same size in the sky, which is why we're able to get a total solar eclipse, because it is about the same size of two objects, one completely covering the other. There is one big catch, though. And the reason we don't get these every month is kind of the problem. That was the follow-up questions to a lot of kids I talked to. It was like, okay, they're the same size in the sky. That's very cool. But why don't we get them every month? Because to go around, it takes about a month for the moon to orbit the Earth. Well, why this doesn't happen every month has to do with two things. It has to do with how we move and how the moon moves around us. So in a perfect universe, we would get a total solar eclipse or some such type of eclipse once a month, right? When a new moon occurs in a perfect world, that every new moon, that the new moon would happen and it would move in front of the sun. But we don't live in a perfect world. We live in a world with ellipses. So we don't orbit in a circle. We orbit in an ellipse. And because we orbit in an ellipse, we have one point where the Earth is closer to the sun and another point where the Earth is farther from the sun. And if you remember our equation from before, distance has a really big impact on how big something will appear in the sky. And this is called perihelion and aphelion or aphelion. I actually don't know how to pronounce it. I only ever write it down. This is how much those things change, right? The sun is much harder for us to see because you shouldn't look at the sun. Don't look at the sun without the proper equipment. We wouldn't notice it anyway. Don't do this. But it's much easier to see with the moon. So this is often in the terms of like supermoons, right? When the moon appears to be very large in the sky, it's actually because it's at its closest point to Earth, what we call perigee in this case. So the moon orbits us in an ellipse, and we orbit the sun in an ellipse. And because of that, these two objects will appear different sizes depending on how the distance between us and them. So some cases the moon appears big, sometimes the sun appears small, sometimes vice versa. But when they're perfectly right around each other at the same size, the moon will cover the sun, and you will get a total solar eclipse. When that doesn't happen, you will get an annular eclipse. So this is when the new moon occurs at apogee, at its furthest point from Earth, making its angular size smaller than the sun. And so you get that ring around it instead of having it be completely covered.
That's very cool. I've always kind of like intuitively knew that was the case, but you really laid it out really well here. And of course, talking about our favorite two holidays, perihelion and aphelion too. So as we had one recently, we had an annular eclipse happen last October, which we talked about with the folks down at Terry Fox Secondary, right?
Yes, yeah, that was the one that just happened. And this is another question we get. Okay, they have to be the same size in the sky, right, for it to be total. It doesn't happen once a month because things are closer or further away, right? But there's a second reason why we don't get them every month. And that's because not only are things elliptical, things are tilted. So if we were to actually look at the moon's orbit around Earth or even the Earth's orbit around the sun, it's not this straight line. We decided to put it a straight line in terms of the frame of reference of the sun, just because it's easier to deal with it that way. But the moon is tilted relative to that, right? So the moon doesn't actually orbit us in this nice straight right in the middle. It actually is tilted a little bit up and a little bit down. So sometimes the moon, as it comes around Earth, it approaches new moon, but it's way above the sun or it's way below the sun, and it misses the sun entirely. And this has to do with the movements of the both objects. So in this diagram, I have the sun, I have the moon and their orbits, and the green ball is Earth. And I hear you, Marley, the sun does not go around the Earth. I know this. I know. This is what frames of reference are. It's okay. So this is the best way to explain it. Because from our perspective, we see the sun moving throughout the sky. We know this is because we're rotating, but even its rising and set times, that changes as Earth moves around the sun. But from our perspective, it looks like the sun is moving. If you've ever seen like the trace of the sun in the sky at the same time, makes that figure 8. But as it moves, what we call that is the ecliptic. So that is when the path that the sun traces in the sky as we orbit it, we view it as tracing the specific path that we call the ecliptic. And that's what this yellow line is. And everything we do when we take measurements in this case is relative to the ecliptic. So you can think of the ecliptic as horizontal, our bar, our centering point. The moon's orbit is tilted relative to the ecliptic. So it actually is a bit offset. And so eclipses can only happen when these two things intersect. When the moon crosses or intersects with the ecliptic, That's when both objects are in the right spot at the right time for us to view an eclipse. And this happens roughly every 6 months. So we had a solar eclipse in October. Our next one is now in April, which is 6 months later. It's called the eclipse season. An eclipse season happens every 6 months. Will you get an eclipse every single time that happens? Not necessarily, because there's other factors. There's the fact that it won't necessarily happen over your exact city. A lot of eclipses happen over water where nobody is and no one can see them. But these are the times when it can happen. It also has to be during a new moon. So these nodes where they cross over are specifically for when the moon will be in its new moon phase, when it's able to pass in front of the sun. So to answer the question kind of at the top, why do we get solar eclipses? It's really just a cosmic coincidence. We happen to be the right distance away from the sun. The sun happens to be the right size. The moon happens to be the right size and the right distance from us. And we happen to have the perfect amount of tilt with the moon for us to be able to get these nodes in a relatively short amount of time, once every 6 months. There's just other things that get thrown our way, like clouds, weather, and also the Earth being a lot of water. Which leads us to our eclipse event. So on April 8th, Monday morning at about 10:45 a.m. or 10:30, you can start arriving here at the HR MacMillan. We will be having an eclipse viewing event. Eclipse glasses, remember, don't look at the sun without the proper equipment. We have the proper equipment. Michael's modeling them right now. You really can't see anything once you put those on. It's actually kind of stressful. You're muted though, Michael. So this is entertaining for me. I need the viewers to screenshot that.
I cannot see anything, and that's exactly what should be happening. If you have glasses and you put them on and you can see anything, then those are not safe glasses, correct?
Correct. Yeah, it should just be dark. It's actually quite trippy, but the sun is still like right there. It's pretty cool. So we will have those available by donation, and we will also have a live stream going of the eclipse because it's tracing such a large path. NASA has a lot of things up and ready to view, so we'll have one of those going on as well. The maximum view, so the most that the moon will be covering the sun for our eclipse, will happen at about 11:30 in the morning. With about 17% coverage. And the reason for the live stream is because we live in Vancouver and it's April, so it's probably going to rain, and I want to avoid as much of this as possible. I know it's annoying and it's very frustrating, but no one can control clouds, unfortunately. So we have provided a fail-safe. Someone will stream it, NASA will stream it, we will have it. And in that case, you'll actually see totality in that case, because the NASA live streams, I'm sure they'll have someone set up in the path of totality as opposed to just a simple little partial. Not that simple, still very cool. But that is all I have about eclipses. I'm sorry I made you learn trigonometry, but that's how you know what's going on.
Well, this is amazing. As you talked about, the specific geometry plays a big part in time and sort of like our relationship with not only like the moon and the sun, but all of the planets. One question that I've gotten before in talking with kids about this, do other planets experience eclipses? Because it seems as if we have a very privileged place in our solar system where we have a moon that just happens to perfectly cover the sun at certain moments. But can that happen anywhere else?
Yeah, like Mars gets eclipses. It's just that its moons are so small that they just looks like they just transit in front of the sun. They don't cover it entirely. It's really just coincidence that we have a moon that appears to be the exact same size in the sky as the sun for us to get a total solar eclipse. Like things moving in front of the sun, if you've got a lot of moons, might make it more likely. So things like planets like Jupiter, Saturn, they've got a lot going on. Their moons are typically very small, but we just have the perfect formula, the perfect amount of chance encounters that have happened for us to get this, which makes it very, very special that we are able to see what we're able to see when this happens.
Yeah. But what about, let's say you're on Europa. I
Right.
assume then that Jupiter would completely cover the sun, right?
How far is Europa from Jupiter is the first question. And then what's the angular of the sun?
I'm just giving you more trigonometry tasks to do
No, this
here.
is fine because because I can use what's called the small angle approximation, which is this fun whole thing when theta is just equal to the ratio. So if you give me the numbers, I can tell you, right? The angular, I need to know the distance from Jupiter to the sun. I already have the diameter of the sun. I can tell you the angular size of the sun from Jupiter. It's pretty small.
Yeah.
Jupiter is really far. And then Europa, it really depends on how big Europa is and how far it is from Jupiter. If you were on the moon and you saw a solar eclipse, what would that look like? Is a question I've gotten too. Like if you're on the
Oh, right.
moon
Yeah, yeah.
and a solar eclipse happens, what do you see on Earth? Um, and it would look like the Earth or part of the Earth is being covered by the moon's shadow, right? So you
Yeah.
would see much more of Earth, but part of it would be dark, and that's where the moon's shadow would be falling, right?
Wasn't there? No, good. Go ahead.
Because like it's kind of like a lunar eclipse and opposite. When a lunar eclipse happens, the moon moves into Earth's shadow and it entirely becomes red or part of it disappears. And that's because the moon is small enough to fit inside of all of Earth's shadow.
Hmm.
But if you reverse it and the moon shadow goes onto Earth, it only takes up a tiny portion because the moon is smaller than us. So it wouldn't nearly be as exciting.
Yeah. Am I dreaming, or did I see something? Was maybe in For All Mankind? Was there a scene in For All Mankind when they were on the moon and there was an eclipse happening? Or am I thinking of a different show?
I have no idea. I watched that show all at once, and so I don't remember a lot of things about it. I do, like if you were on the moon during a lunar eclipse, it would appear to go red too, if you were on
Yeah,
the moon when that happened. So
that'd be
yeah,
very cool.
that would be very cool. Not like
In-
bright blood red, but it's go like reddish tinge. Yeah.
Interesting. Well, that's really cool that you could basically the math that you just laid out for us, we could do for any scenario, right? Like we could do it for Titan and Saturn. We could do it for maybe even some of the other moons. There's many large moons out there that we can imagine potentially eclipsing the sun because as you get further away, we can visualize that amazingly in our planetarium. The sun gets very small, almost
Mm-hmm.
becomes obscured with all of the other stars out there,
It's
right?
just a dot. Yep.
So very, very exciting to think about. Well, if you are out there, of course, hopefully you are prepared. Hopefully you are traveling. Your Yurt on YouTube is traveling from the Philippines to Los Angeles to see the eclipse. But
Whoa.
if you're going to Los Angeles, you're not going to see the total. So be prepared with those glasses because you're still only going to see a partial eclipse in Los Angeles. If you do want to get in that path of totality, do you have a map of the path of totality?
Yes, I do. This is from Time and Date, which is where I go for a lot of these maps because they're very nicely laid out.
Yeah. So yeah, so I have some friends that are going down to Mexico. We talked with the folks from Terry Fox Secondary. They're going to Texas.
Mm-hmm.
The Planetary Society is having an Eclipse-orama, so they've got a huge event also in Texas as well. And a lot of the Canadian Space Agency and a lot of my friends too are in and around that Ontario, Quebec region, almost going right through the heart of Montreal, right?
Yes, pretty really close. Someone phoned me. I don't know if he wants his name put out there, but he phoned me. He's actually flying to Fredericton to try to see it. That will be an in totality as well.
Yeah, yeah. I've got some friends there too. So I'm so jealous. I mean, like, so I guess the next question is when will we,
Mm.
I guess here in Vancouver, when will we ever get a chance to see a total solar eclipse?
Long after you and I have both stopped existing on this plane of existence, unfortunately. It's just one of those things where it's just sucks. Like we're just in the wrong spot. Like it's just a bad place to be. Um, the next total solar eclipse is not visible before the year 2200. So yeah, for here, you'll
Will we
have to
even
go
still have a
elsewhere.
planet to view a total solar eclipse?
Yeah. It's just, a while from now will
Okay.
that happen. But there'll be eclipses around the world, just not right in this location, right? Like there's
Right.
about 2 or so eclipses every year. You'll get something,
Hmm.
usually about 6 months apart. So, don't yeah, if I filter it specifically to North America, oh no, wrong spot. You can do this on timeanddate.com. Like you can just
Hmm.
see because we know how everything moves. So you can really just figure it out.
Hmm.
And for a total solar eclipse to be visible where we are, yep. Yeah, it's not until 2200 unfortunately
Okay.
on our side of there'll be like another, partial view, right? In 2033. Um, but yeah, it's a really big cosmic coincidence that they happen at all. So let's not get too greedy, I
Yeah.
think. I think,
Well,
yeah.
and what's funny is that with anything, there's always some backlash, and I see sort of like this chatter of people of just people thinking that people traveling towards the totality are crazy, that
No.
they are making a bigger deal out of nothing when it really is a once in a lifetime event if you want to see this where you live,
Hmm.
because they'll end up being in very, very remote places, which is why 2017 was such a big deal because it went through such a populated area. And this one too is a big deal because it's also going through a very populated area.
It is, and
However,
like many of them, like
yeah,
across the continent, like it is very, it's a very special um event for it to happen. And yeah, they're not silly for traveling. Like
yeah.
if you have the ability to do so, get to totality because it
Hmm.
is apparently, I don't know, never have seen it. It's like a remarkable event to be in totality and to experience that. And
Yeah,
you definitely should get there if you can.
absolutely. And and I think unfortunately, I suspect with this eclipse, there's going to be a lot of disappointed people, just based on the weather. Like the chances
Hmm.
are, there's going to be lots of regions. There could be even the majority of the East Coast, right? Although weather's looking actually pretty good for a lot of the East Coast right now. I was talking with some friends out there, and the forecast is actually good for like the Ontario region.
Good.
But you never know, right? It's April, this is springtime, and there's a lot of moisture in the air. So if you get a chance to see that total eclipse, come on to our next Ask an Astronomer and tell us all about it. Keith asks, if we were on the moon watching an eclipse, what would be the name of the type of eclipse caused by the planet?
So if we are on the moon and we're watching a lunar eclipse,
Well, I guess a planetary eclipse. Is that what you'd call
no,
it?
yes,
So it's
so, no, we're like we on the moon are moving into Earth's shadow. Is like a lunar eclipse.
yes.
Yes. Okay. So if we're on the moon and we're moving into Earth's shadow, what we are seeing is Earth covering the sun, and so that would be a solar eclipse.
Oh, it'd still be okay. So even
Mm-hmm.
though it would be a lunar eclipse for the people on the Earth, for
Mm-hmm.
the people on the moon, it would be a solar eclipse.
Mm-hmm.
Okay. Very, very.
Perspective, frames of reference. The thing in
Well,
ninth grade that almost made me fail physics. Look how far we've come.
well, this is really fun because at some point, and maybe even in our lifetime, right?
Mm.
This may actually happen if we have astronauts on the moon. They will experience a solar eclipse, while for us, we will be experiencing a lunar eclipse.
Yeah. Yep.
This is a future episode of Ask an Astronomer 20 years from now, for two people that are not us.
No. No. Fingers crossed.
And they're going to be talking about this exact thing that we brought up here
Yeah.
on this episode of Ask an Astronomer. Thank you all so much for joining on this episode. We will be back in 2 weeks with an Earth Day edition on April the 18th. We've also got a special event happening that night. We've got the podcast The Illusionist,
On
which
the
is all
18th or
about
the 16th? Oh, yeah, that is. Okay. Thank
yeah,
you.
the
It
18th.
is 18th. Okay.
It panicked me for a second there.
No, it's okay.
Um,
That's my state of being. So don't worry about it.
the Illusionist is a podcast all about language. So they're going to be delving into lots of different topics in and around how we name things in the universe. The most recent episode was actually all about craters and kind of where namings of craters come from. It's a fascinating episode. So they're going to kind of keep going along that vein, but they're going to be in the planetarium, even playing some music and some songs. It's going to be a fun event. And then Marvin's going to be down in the auditorium talking about the weird language that we associate, things like spaghettification, and
Hmm.
what are some other terms you're going to be delving into?
Blazar,
Okay.
quasar, syzygy is always fun. Flavors of quarks is a really hilarious thing that bothers me a little bit. Galactic cannibalism. That's always a fun word, a fun phrase to throw around. So, you know, things like that. Also, things about how astronomers are bad at naming stuff. We do love to do the what it says on the tin kind of name. So, like
Mhm.
hot Jupiter, it's a Jupiter-sized planet. That's hot. So, you know, things like that.
Okay, well, if you want more of that, you've got to get a ticket to that event. But plus, we also have an Earth Day event, which is a couple days later on April the 20th. It's not the official Earth Day, but that's when we're going to be doing a collaborative event with the Museum of Vancouver and the Maritime Museum. So lots of fun events. Go to spacecenter.ca to check all of those out. And we will see you in 2 weeks right here on these channels. Take care, folks.